Hello again, and we shall be finishing up the problem set 2 solutions with problem 4. This problem asks us for a solution strategy for part B, but since I pretty much see A and B as being the same problem, I'm going to give you a solution strategy that I'll use for both, but the B is just more complete than A. So, the first thing I want to do is basically see how each of these rules is related. So we have 4 rules. I'm going to call them rule 1, 2, 3, and 4. And so I look at this and I notice that it says they are ordering a pizza to share, which means every person in this problem wants to be able to eat this pizza. So we have to find a solution that all of them like. So I'm going to be ANDing each of their individual expressions together. Then, after I AND each of their expressions together, well, actually before I AND each of their expressions together is what I meant to say, I need to figure out what each expression will be on its own. So I'm going to solve for 1, then 2, then 3, and then 4 in Boolean logic, and then I'm going to AND all those expressions together to find my final expression for a valid pizza. In part A, I'm only going to need Adam and Ben, so I'm just going to need 1 and 2, but in this one, I'm going to need 1, 2, 3, and 4. So, to start, let's look at Adam wants pepperoni or cheese, but not both. So, as I mentioned in lecture, this could be pepperoni or cheese, and not both. So, both is and not is not. So that's one way, which we also know is equal to P, X, or C. So that's rule 1. Rule 2, Ben wants sausage if the pizza does not have pepperoni. So this is our if A, then B constructed inverted. So our A condition is pizza does not have pepperoni. So we need A bar, and our A is equal to P bar. So we're going to need P bar bar, which is just going to equal P, or B, and B is sausage. So this is just equal to P or S. Okay, here we have Carl will not eat pizza with sausage, but not anchovies. So here we know this tells us we will complement the entire expression that we have for the pizza, because he will not eat the pizza. And then we have here with sausage, but not anchovies. So this first part, sausage, but, so that's an and, not anchovies, a bar, will not eat. And so we're going to have to complement that full expression. And then finally, we have Donald hates anchovies. Well, we're just going to assume that's A bar then. So that A equals 1 if the pizza has anchovies, 0, and so on and so forth. So I kind of guessed this already. So write a Boolean expression that is 1 if and only if Adam and Ben will both eat the pizza. So Adam and Ben are just expressions 1 and 2, so we're going to AND. So pizza is going to equal 1 ANDed with 2, which is going to be P, X, or C ANDed with P or S. And we do not need to simplify. Same strategy here, I've already got this. And now all 4, so it's just pizza equals 1, ANDed with 2, ANDed with 3, ANDed with 4, which is just going to equal all these different expressions put together. So P, X, or C, ANDed with P or S, ANDed with, actually I'm going to do the De Morgans here so you get to see that. So this is S bar or A. So I've complemented each of my variables and changed my symbol. So this is S bar or A and A bar. So finally, for part C, I need to write another solution strategy. And so the solution strategy I would want for this one is basically I need to come up with a singular expression for, or something that's very easy to read. This is kind of complicated. I don't really know how to read this. I could go through and compute every single possibility, but if I'm going to do that, why not make a truth table? And so, because the truth table is going to list every possibility in a nice, easy to read format, and since I have 1, 2, 3, 4 variables, it's going to have 16 rows. It's not too big, and I can just evaluate the expression that way. That way I know I've checked every possibility, and I can see what's going to work and what's not going to work. So that's basically my solution strategy. So I'm going to fill this out, find the rows that give me a 1, and those are the toppings that can be on the pizza. So I've got A, C, P, and S, and valid pizza. So we've got to fill out this. So those are my terms. Sorry, I had to start squishing that a little bit. So now we just basically need to evaluate this expression for each of these terms. So I immediately know, since this A bar is out here, that anytime there's anchovies on the pizza, all these are going to be 0, because 1 complemented is 0, and 0 ANDed with anything else is 0. So all of these are 0. I'm going to put a line across this so we can see where those bottom 8 are. And now we're looking at the top 8. So we need a time when we need pepperoni, X, or cheese. So that's when one of these two are true. So that means these two cannot be true. And these two cannot be true because those have both pepperoni and cheese. So now we're left to these 4. So we're down to 4. We have pepperoni or sausage. So anytime we don't have pepperoni or sausage, that's going to be 0. And now we have sausage, bar, or anchovies. So S bar or anchovies. So this is S bar and A bar, so that's 0. Oh wait, sorry. S bar, this has got a 1, sorry. Because this has S bar. That's S bar. And then this has S, and so this would be S complement, which is 0, and A, which is 0, so 0 or 0 is 0. And then we have, same thing here, S bar is 0, or to the 0 is 0. So the toppings are just pepperoni. And that is all we need to do for this problem.